So once we can put the numbers in the calculator correctly, now let's look at the meaning of the numbers. If you're in the lab and you're measuring the temperature, here's a thermometer in degrees Fahrenheit. You're trying to record this temperature. Notice the marking is showing you a temperature that's greater than 100 degrees, less than 110 degrees. This line in between, halfway in between 100 and 110, must be 105. So if you count the little lines, there's 1, 2, 3, 4, 5 lines, you hit 105. So each line, or each mark on this particular thermometer, is 1 degree Fahrenheit. Not every thermometer is going to be calibrated the same way. You could have markings every 1/10 of a degree or every 100th of a degree. So you have to look at your instrument to figure out what the meaning of this measurement is. The key when you're recording the temperature is to record things with the correct number of digits. So if we look more closely, the temperature is greater than 100. We know it's greater than 101, 102, 103, but it's not yet 104. So the temperature is somewhere in between 103 and 104. How do we know which we should record as the actual temperature? And the rule is you always estimate one decimal place past the smallest marking. So in this example, if we have marks to every degree, we have to estimate one place past that. And so if I estimate that this temperature is greater than 103 but less than 104, I have to look how far in between it is. If this was very close to the 103, I might read this as 103.1. If it was very close to 104, it might be something like 103.7 or 103.8. Each person is going to get a different estimate. So if I'm looking at this, I would say it's not quite halfway between, so maybe it's 103.4 degrees Fahrenheit. Someone else could read this as 103.5. They might see it as halfway between 103 and 104. Both of these are legitimate readings. What would be incorrect is if you put too few or too many decimal points. So some people think that in science we don't estimate things, but in an analog device like this thermometer, we're always estimating. We're estimating that last decimal point or decimal place. If someone wrote 103.36 degrees Fahrenheit, that cannot be read from this particular thermometer. You would need a thermometer that's marked to the 10th place in order to get an estimate to the 100th place. So this would be an incorrect reading. And the numbers that you write down for your readings are very important when you're doing calculations. One other thing to notice about this, if this had been a digital thermometer, in the lab we're going to be using digital balances. Digital devices are a lot easier. For a digital device, you just record all of the digits. In other words, there's no rounding at all. It's only for something that's analog like this that you have to estimate that last decimal point.